Hey, if you guys are watching this, first of all, my name is Chris, and I wanted to make this video as a way just to kind of take a look at geometric threads, both in Inventor and Modo. I'm going to be using Modo as an example of this, but the same thing, I guess, could be said for Cinema 4D or something like that. Traditionally, I've done most of my modeling in CAD, and the reason for that is for the industry that I work in right now, many of the parts that we make are threaded parts on both ends, whether that's ANSI unified threads or MPT or metric threads or something like that. And I find that stuff very hard to do in a traditional polygonal modeling system. However, I've seen some examples here lately on the Modo Discord channel of people who've been trying to do the threads, because I was asking about threads, or I made the comment that Modo wasn't very good at doing that, and I see now that the capability is there. And one of the things I want to kind of answer for that is what you do for certain things like thread reliefs, how to start and stop a thread, when you would use that, what the cutbacks would be for that, certain things like that, and then just kind of show the general dimensional characteristics of what makes up something like a ANSI unified thread. Anyways, if you guys can bear with me for a little bit here, I'm going to try to incorporate all that into this video and kind of give you guys a roundabout way of seeing how that's done. And then if you'd like to assist on either something like Modo or Cinema 4D on kind of how to mimic what I'm doing in CAD, I know I would appreciate that. I'm sure everybody else would. So let's take a look at what we've got. Okay, so to kind of just start off real quick here, let's take a look at what the thread actually looks like. So in an ANSI unified thread, one of the main characteristics that makes that up is the fact that you have what looks like these rounded triangles that have a 60-degree inclusive angle between them. And then you have what they call the thread height. That goes from, you can kind of see these two lines I've got right here, or I've got as construction lines. Let me change this real quick so you guys can see that. If I change those to regular lines, you'll see that this kind of makes a triangle. So from the point of the triangle down to the valley, or the reverse point of the triangle, is what they call the thread height. The distance between the points is what they call the pitch. That's how many threads per inch you're going to have. Then you've got your 60-degree angle, 30 degrees off the center line, and then you've got these two rounding factors right here. You've got the top of the thread for a male thread, or the bottom of the thread for a female thread. And then those have certain geometric relationships to one another. So we'll take a look at that. Let me turn these two back to construction lines here. And if you guys are Inventor users and you wonder how to do that, you can either just right click on the line and just change that to construction, or do what you can change it to a center line. So for example, like I will change this one to a center line because that's what it is. Okay. So let's take a look at what we've got here. So again, there's four main things, or five main things that make up this thread. One is this angle, 60 degrees. Okay, that's just normal for ANSI unified. Then you've got your pitch. Again, that's the distance between the peaks or the valleys. And then you've got your height. Now the height is a relationship of the pitch, because the two main dimensions that control this are the pitch and this angle. The height technically would be considered a reference dimension, because you can't, once you place that dimension, you can't change it. And the math for that is as follows. Let's jump over here. I've got a sheet that I can include with the video if you guys are interested in that. But basically it takes everything out of the machinist handbook and kind of condenses it down. But when we look at this, sorry if my computer will catch up here. I've got a copy of this in here. When you look at the height has it's kind of like a equation. So height equals the height of the sharp V thread times 0.86603, or it's pitch times 8.6603. So it's not exactly, it doesn't exactly come out to 60.0000. It's more, it's like 59.9997, whatever. Anyways, that's the mathematical formula for figuring out the height. So let's go back here to Inventor. Sorry, I've got my resolution for my screen way down so you guys can see what's going on here. All right, so with that said though, that means we only need a couple dimensions to actually control this thread. One of the things that we need is we need to know what this nominal value is. So if this is a male thread, so that would be a thread that's on the outside of something, such as like a bolt or all thread or something like that. That means the thread is on the outside. We're going to need to know what that nominal OD is to make that up. Then we're going to need to know how many threads per inch that we're trying to do. So most people are familiar with something like 1/4-20. If you guys have cameras or something like that, they run with a 1/4-20 or a 3/8-16 thread, and that means it's 20 threads per inch or 16 threads per inch. Guess we're just going to bypass that for right now. Okay, so you guys get the picture of what's going on there. Let's run back to the part. All right, so now what we're going to do is use the Cool Orange plugin tool, and we're going to see it cut physical threads. So if I go up to this Cool Orange here and I go to Thread Modeler, it's going to ask me to pick a thread. I don't have that visible yet, so I'm going to go back here. Thread Modeler, I got to pick a thread. Here's my thread. I hit OK. Now, two things are going to happen here. It's going to build the thread way past the end of this part because I did not have full threads on. So let's go back here. We got to unsuppress this, and then we're going to go back into this. You'll see that it was kind of giving us stuff out here. So what I want to do is do not full thread, but I want to, oh, well, I guess I'm going to have to do the math in here. So I'm going to say 0.75. There. So this is 1 inch long. I offset 0.25. Now I'm at 0.75. So now I'm going to do the, pick my thread again, and it should just go to the end of the part right here. And there you go. Now, two things have happened here. I don't know if you guys are used to solid body modeling, but this is what's happened. When I run the Cool Orange tool, it's created a second solid body that represents the threads, even though it cut material away from the first solid body. Normally what I do is I go up to 3D model, I go to combine, I pick both of these solids, and then I just combine those into one. And you'll see why in a second. So now I've got one solid body. I'm back to one solid body. So this is what we've got right now. It's physically cut the threads. Now, here's the interesting part. When I look at this from a side view, you'll notice that the top of this curve is tangent with the edge of this surface. What we're getting here is what I was trying to show you over here, where this whole thing is kind of moved up. And with that in mind, what we would want to do in this case is you would want to have your sketch set, if you're doing this just to cut realistic threads, you would want to have your sketch set where this is moved up to match. That might not be what actually comes off the machine, but this is what we would want to do to kind of make this look correct, I guess, because otherwise you're going to have this little step down here, and I don't necessarily think that that's how it's going to come off the machine. Because when you look at this on the machine and you take a measurement of the shaft and you take a measurement of the top of the threads where the curve is on the tangent, they're the same number. So in order to make that happen, what we would have to do here is we would kind of have to set this, we're going to have to write an equation for this. So right now I've got this offset from the center line to the top of this little dotted line right here, set to nominal OD divided by 2. What we're going to do is we're going to change that, because that little offset of that line is this height divided by 8. So we're going to do some addition here. So what I'm going to come in is I'm going to hit D for dimension. I'm going to click on this dimension. And where is, oh, I got to make this sketch active, sorry. So we're going to hit D for dimension. Actually, let's not even do it here. I'm not going to make this sketch active. We're going to do it over here in the parameters. So what I've got right now is this D45. That's nominal height diameter OD divided by 2. What we want to do at that point is, you see this thing, this D42 height divided by 8, we want to add that in. So I'm going to put open and close parentheses around that little equation, and then I'm going to add in this height divided by 8, which is D42. So we're just going to say D42, and we're going to hit done here, and you should see the whole thing move up, which it did. So now what we've got is we've got that tangent circle right in line with this edge of the surface. So this is kind of mimicking now what we're getting on that Cool Orange plugin. So let's go back to the Cool Orange plugin and take a look at this. Oops, sorry. Well, it did write them here. And what we'll do is we want to draw, let's put a dimension here. And we're going to see we're going to get the 245. And then what we want to do here is also grab a dimension from here to here. And you're going to see that we also get the 245. So we know that these dimensions are the same. If we change this decimal place on this to precision out to 4 places, it's 2449. If we change this one out to 4 places, 2449. So that's what we want, and that's kind of what we've mimicked over here. Okay, so there's that. Now what I want to do is show you guys kind of what the relief cut stuff is. So let's just keep this in mind, because you remember I combined this, and the reason I did that is, I'll just do this real quick here so you guys can see, but a traditional relief cut on this would be cutting a chamfer around this. So what I'm doing is I'm doing my chamfer in a different way. I'm just drawing 2 circles, because I know I can always choose the edge of this or the face of this thread after I've combined them. If you want to automate the chamfering, you would do it this way. You would not draw a triangle and then try to revolve it. This ensures that I can grab that face every time. I'm going to do a cut because I want to cut through the material, but I want to cut through the material at a negative 45-degree angle. And you'll see what's going to happen here is it's going to cut down just like that. It's going to leave all this, but just cut out that area right there. And then we end up with this nice finished off thread that has a chamfer on the end. So that would be like our leading relief cut, is just a chamfer on the edge so it can engage into the female thread. Okay, where are we at for time here? We are 25 minutes. Okay, so let's run over here and take a look at, you kind of already saw this where I put a thread on there. Let's go to an actual part where we're going to cut a thread on here. So we have let's just say we have a part here that's going to have a thread here, and it's just going to act as maybe like a plug. And we've got a set of wrench flats that we've cut in there as well. So what we want to do is find out what the diameter of the shaft needs to be for our thread, and then do a relief cut on the front and what we call the bottom of the thread. So this would be the front of the thread, this would be the bottom of the thread. And there's 2 ways to look at doing the relief cut. One is that you're just doing a relief cut just so you can finish that thread out and have it nice, and your stuff's not going to crack or break or things like that, but it just looks cleaner. Or 2 is this part might end up having an O-ring that slides over the thread to seal this part if it's a high pressure part. So we'll just take a look at what we got here. So let's measure this shaft real quick and see what we've got. So M for measure. If my software would catch up here. No, sorry, I got windows opening on other monitors. Okay, let's measure this part and see what we got. So if we measure this diameter, we've got 446. Okay, so it looks like we've got, and what is this diameter? This diameter is 625, and this one's 1/2 inch. Okay, so let's take a look at our parameters and see what we've got. So we've got our main OD here. We've got our thread OD. You know what? We're going to call that nominal OD because that's what it's called in the sheet. We've got our thread depth, I guess. That would be this one. Yep. Thread depth. Then we've got what's this 0.5? We got to figure out what that is. And then the rest of the stuff is for the wrench flats. So let's figure out what our 0.5 is. That's this one. So let's change this. Let's change this to 0.625 so we don't get these 2 mixed up. And then I believe this is our 0.5. Yes. So here we're going to go 0.52. That way I can tell what's what over here in the parameters. All right, so 5.2 is the thread depth, and 446, we don't know what that is. I'm turning that back to D31. Oh, that's my, I'm getting this stuff mixed up. 1 second. So we're going to run this to D29. This is nominal OD. Sorry guys, bear with me. And this is our thread length. Okay. Duh, can't do a space. Thread length. So this is our OD, and this is our, let's see, this is body length. So what we want to find, and then the rest of that is for the wrench flat. So we know we want the thread, we want the nominal OD and the thread length to be keys, key values, and we can go ahead and make this key value as well. And then it doesn't matter in the wrench flat stuff. We'll just keep that at 5/16 or at 9/16 for right now. Okay, so we're going to go over to iLogic. We're going to run a form. We're going to drag these dimensions over. So we've got the OD, the part OD. We've got the body length. We got the nominal OD and the thread length. And let's go ahead and grab a splitter and put between those two. You know what? We'll put another one in there too. It's just going to give us a little bit of a gap. So there we go, right there. All right, so now we can change any of these. So this can go to 0.75. This can go to 2 inches, whatever we want to do. So we're going to take that back to 625, and then we're going to change this to 0.5. All right, kind of back where we were. And then we have a nominal OD and a thread length. So here's our nominal OD is where we're going to kind of reference our sheet over here, our Excel sheet. So what we're going to do here is we're going to put in a 3/8/16 class 2 thread. So when we look at this sheet right here, what we're going to see is that in order to run a 3/8 inch thread, we want a nominal OD of 3690. Okay, and that's coming from this number right here. So 3690. That's what we want our nominal OD to be. So let's run back up to Inventor, and we're going to type in 0.3690. Now that's going to be what we need for a 3/8/16 thread. Now the reason I know that is because if I come over here to 3D model, choose the thread tool, pick that diameter, it's automatically going to pop up 3/8/16. Now I can change my threads per inch here. Okay, so there's a lot of options in here for threads per inch. And let's just take a look at what some of these are. 16, 18, 20, 24, 27, you guys can read the rest there. Now what we want to do, now we're doing this with the thread tool and the Cool Orange, but then we're going to look at how to do this manually where we make our own sketch on there. Now what you're seeing here is exactly why I do not like doing it this way. Because now I got to create a sketch, I got to project 2 things to make sure I've got the right one. But we're going to run through it and show you guys how to do this. So if I were to do it this way, what I would do is I would draw this out to a certain, whatever, let's just say 0.3. And then I know that my nominal value here for the diameter, let's just draw a line here. And let's say that from here to here is going to be nominal OD divided by 2. And there, now it's drawing that line nice and tangent right on the top of those curves. So what I'm kind of figuring out here is where my chamfer needs to go. Now, here's how the formula works for the chamfers. So what I've got here is I've got this column that says chamfer OD external. So when you look here at 3/8/16, you know that the chamfer, if you do it the way that I'm going to show you how to do it the second way, you would just type this in for for that first circle, which would be 0.2792. So we know it's 0.2792. Let's just remember that. Okay, we're going to go back up here, and what we're going to do is we're going to kind of draw this down at an angle. Let's just do it like that. And then we're going to say that this is 45 degrees. Because we're cutting the chamfer, basically. Now, I'm going to hit F7 to section this part. Obviously that's way too big, but what we want to do is we want to have this dimension from here to here be the 0.2792 divided by 2. And what that's doing is it's moving it out here. Now this is kind of why I don't like doing it this way, because the cool orange the cool orange is not technically correct or cutting correct threads. They're cutting threads for you to physically see threads, but they're not geometrically correct. They might argue with me on that. But the reason I know that right now is because, look, if I cut my chamfer right here, I'm completely off the part. And we want a smooth chamfer cut. We don't want any bit of that chamfer being off the part. So if I were to run this chamfer around, you'll see what I'm talking about here in a second. So if I were to hit R for revolve, pick that, and then pick this as my axes, and we want to cut, you would see that it's getting ready to cut the chamfer around the part, but it also left this hard, sharp edge right here. And you see how I've got these individual segments? We don't want that. So in this case, what we would end up doing is kind of backing this down a little bit. So what I'm actually going to do is just delete that dimension. And then I know that I kind of want to just back this up. I want it up here on this surface some place. Okay, so if I were to cut it right there and then we hit finish sketch, now you're going to see that this surface that I've got highlighted, that's the complete chamfer cut. And it's come right up all the way to the edge, because now I know when I highlight that circle, the whole thing highlights. So I know we've done it correctly. Now, to show you why I say that the cool orange doesn't cut the thread technically correct, I want to show you this. So if I draw a dimension from here to here, let's draw a new sketch right here on this plane. And then what I'm going to do is I'm going to project my entire cut edge surface, hit F7 to section apart. And then what we're going to do is we're going to eyeball this, because Inventor doesn't let me pick those edges. So we're just going to kind of eyeball this line right here. And then we're going to eyeball this line right here. And then we're going to measure the distance, or the angle between these two, and it's 55 degrees. So it's not 60 degrees. If you want to see something that looks 60 degrees, what we would do is draw this line up straight. And then let's bring this down to where I think the corner would be. Sorry, if it would let me project all this stuff, I would do that. Okay, so if we bring this there. So if I were to draw 30 degrees from the center, you would get something that looks like this. So we already know that, technically speaking, the cool orange plugin is not cutting 60 degree threads. It's cutting 55 degree threads. I don't know why it does that. So we have to kind of be careful when we're using that tool. If you're going to use that tool everywhere, if that's what you're using to cut your threads, fine. Just use it everywhere. Everything will be fine. Female threads will sit inside of male threads, and when you section them, you'll have, a nice little gap, and they'll follow the same profile. But what you don't want to do is mix and match. You don't want to physically manually cut threads one way and then use the cool orange in the other one, because they're not going to line up. So let's go back over here to our test piece. The whole point being, though, is that we've got this nice chamfer on here. Now I'm going to show you how to do this the way that I do it, because this way allows you to automate this. We know that every time this thread gets created, this surface gets created. So if I want to later come back and change the threads up, this is the benefit of cutting the threads manually versus using cool orange, is when you cut the threads with cool orange, let's go over here to this part and let's finish the sketch. Let's say I messed up and I didn't want quarter 20. I actually wanted like quarter 24. Well, first, two things have happened. it is suppressed this thread detail, and what it did is it created a sketch profile here of the top and the bottom of the thread. Then it created this profile. Then it ran a coil. It created this coil feature down here. And it ran that coil between that top and that bottom line, cutting that information out. And it saved it out as a completely different solid. So what we don't have the capability of here is going back and physically changing our threads once you've done this. So if you use Cool Orange, here's the process for changing from quarter 20 to quarter 24. Okay, one is you've got to delete everything up to the thread. So you're basically deleting all your work you've done, including that chamfer. Now, I'm going to show you why my chamfer works though. So let's do this. Let's move our end of part above that chamfer, and then we're going to delete the combine, the coil, and the 2 revolutions. Okay, so we're going to delete all that. We're going to unsuppress the thread. Then we're going to edit the thread. We're going to go in here, we're going to change this from quarter 20 to quarter 24. So 24 threads per inch instead of 20. Then what we're going to do is we're going to go back up to Cool Orange. We're going to hit Thread Modeler. We're going to pick that thread again. We're going to run the whole tool again. It's going to recut the thread. And then we're going to go to the 3D model. We're going to hit Combine. We're going to pick those 2 solids. We're going to hit OK. So what we're going to do here is we're just going to hit Redefine. Where is it at? Sorry, we need to do that on the sketch, not the... We're going to hit Redefine Sketch. We're going to pick that surface. And our chamfer's there, but we're getting this kind of, you know, this question mark of, hey, you had projected some geometry. It's not there anymore. But I did not project any geometry. But what we've got is 2 circles here. This one being our inclusive line that's going all the way around. This is kind of what we had the last time when we manually cut it, is that line was sticking off. So we had these little segments. So all we're doing here is we're doing a chamfer cut. We're just doing it with 2 circles instead. And then we're going to finish out that cut. Yes, I don't know what the problems are in the sketch. We're not going to worry about it right now. Okay, so there we go. That's what we've got. We cut our thread, we changed it. That's how you do it with Cool Orange. It's not very user-friendly. You can't go back and just change it. It's one of the things I like about SolidWorks, because when you cut physical threads, the thread tool stays active and you can change it on the fly to whatever you want. So now what we got to do is figure out how to manually cut these threads on our end. But I also wanted to show you the relief cut here. So here's what we're going to do. We're going to do our front relief cut, which is 2 circles. This circle being someplace on this face where it can completely cut everything on top of that face. And then this second circle being something that's just bigger than what we think it's going to be. All right, here we're going to put a dimension. Before it was 2792, but that kind of got us off, remember? So we don't want that. So what we're going to do here is go 2792 minus 0.01. Okay, we're going to cut it in a little bit bigger than probably what we need to, and we're going to run with that. We're going to pick the area between the 2 circles. We're going to say cut material at a -45. There, we've cut our front relief cut, and the reason we know it's worked is because when I highlight that circle, it goes all the way around. Now we want to do our back relief cut. Back relief cut I usually do with a sketch. So we're going to sketch on this plane. We're going to F7 to section our part. We are going to project that center axis and this face. Now, what our back relief cut is, or our bottom relief cut, what that is going to entail is, if we were to draw an imaginary line right here where this, the bottom of this curve is, let's just say it goes from here to here. We're just kind of eyeballing this for right now. What we want to do is be 0.02 below that. And then we want to come up at a 45-degree angle, and then I just go all the way up to whatever that surface is. And we're kind of cutting our the profile that we're going to sweep here, or we're going to revolve. So what I'm going to do now is say, first of all, we're going to set this part here, and we're just going to say whatever that dimension is, we're going to be okay with that. So let's just say it's that. Then we want this dimension here to be 0.01, because 0.1 on this side plus 0.01 on this side gives us total 0.02. And that's what we want. We want 0.02 smaller than the bottom of our thread. And then you guys are going to just set whatever you want this distance to be. And in this case, we'll just go 0.05. So what we're going to end up doing is cutting or revolving. I'm going to make this a construction line. This profile around that thread. So if I hit R for revolve, pick that profile, pick that as what's being revolved around, hit cut, this is what we get. So there, we performed our bottom thread relief. Now what we want to do here is go on, we're going to add a radius in here. We're going to probably do 0.03. That's normal. And then some people do this, some people model this in. I do it in Moto so I can get that nice reflection on there. But on this one, I'm going to go 0.01. So there we go. What you guys are seeing here is a thread relief cut on the top and a thread relief cut on the bottom. The top one is 0.01 total, smaller than that top surface. That'll give us a complete line. And the bottom relief cut is 0.02, larger than the tangent at the valley of the male thread. And then if you guys wanted to, you know, you could throw a fillet on here. Where did my window go? I'm missing it someplace. There we go. Let's just go with like 0.15, 0.015. So there, that would be kind of how you would do this. And what this gives us room for later, the reason we do that relief cut is one, it gives a way for the threads to end naturally. So they can sweep and sweep and sweep, and then right here, it's just performing basically this reverse chamfer into this nice finished cut. But two is if I wanted to do another solid on here for like an O-ring, I know that I can come in now and let's just do like 0.07. I know that I can set this O-ring in there and it will be, it'll work out just fine. And if you click this button right here, it'll create a new solid. That way, if you're exporting out to something like Cinema 4D or Moto, you'll get two parts here, not just one. So there you go. So that would be a way if you wanted to run an O-ring in that spot or something like that. But for the most part, you're still going to finish that off. Now on something like an MPT thread, let's go back over to, let's do something like this. MPT is a little bit different because it's a tapered thread. So what I typically do on that is we're going to sketch on this face right here. We're going to come back and arbitrary distance. Let's just say something like this. We're going to draw an angle there, and what I'm going to do is this angle is going to be 3.57. I think it's 3.57. Okay, divided by 2. All right, and then we're going to rotate that profile along our, in this case, our z-axis, and we're going to cut that. Now that I've got that taper on there, that 1.5497 or whatever, maybe that's what it needs to be, okay, 1 second. 1.57, no, 5497, I think is what it is. There we go. Okay, now that we've got that on there, if we go up to 3D model and we pick the threads and we pick this tapered surface, it's already going to tell us NPT. So I'm going to grab NPT, and in this case, I don't know why Inventor does this, but if it defaults to 1/2 inch, it's probably a 1/4 inch size. And then I'll just hit OK, and it'll cut those threads. Now, one thing you have to be aware of here for NPT is you definitely want to make sure you have full thread depth turned on. That way it covers the surface from there to there. Now when I come up and hit cool orange and hit the thread model and hit this, it knows it's NPT thread, and it's only going to cut that thread on that threaded surface. Now here on NPTs, we normally don't do a thread relief. You can if you want, but normally we don't do that. What we do is that front thread relief. So let's hit the combined solid bodies. Okay, and then we have numbers that we run for this, but for the most part, just to kind of show you how this works, once again, we're going to cut that circle, make sure that we're getting an inclusive circle on that top surface, and then just cut something that's a lot larger. Hit extrude, cut, -45. Then we finished out our NPT thread with a nice finish. So there you go. And believe it or not, when we do run these models and our customers see this stuff, they can tell whether that's tapered or straight. That's why I kind of like to do the threads in Inventor and then export that stuff to Modo. The problem I run into there is I don't have quad polys on the Modo side, so when I'm trying to do like a bent piece of pipe that's got an NPT on there, it's super hard to get those UVs unless the bent tubing part was created in Modo itself. And what I'm trying to figure out is how I can do that in Modo, or how I can just cut these threads. If you guys could just show me how to draw the profile and do that in Modo, that would be great. Okay, so one thing we have not covered over here is the female portion of the threads. This one's really easy because there is no offset nominal OD or any of that stuff for female threads. For female threads, if it's a 1/2 inch thread, guess what you're gonna do? You're gonna cut a hole that's a 1/2 inch. That's how easy this is. So what we're gonna do here is we're gonna draw a circle off from here. It's gonna go 0.5. Then I'm gonna extrude it all the way through. So all the way through both directions. There we go. And then I'm gonna go up to the thread tool. I'm going to do this. It's going to tell me it's a 1/2 inch thread, 1/2 Fine, we're going to hit cut. Then I'll come up the cool orange. We'll hit the thread modeler. We'll come down here and pick the thread, and then it's going to cut the thread in. And then we are going to combine, and then we're going to chamfer out both sides. Okay, so really easy on threads for female threads. You just cut the initial hole. If it's a 1/2 inch thread, you cut the whole 1/2 inch. If it's 5/8 thread, you cut the whole 5/8 and it fills in the rest. Doing that as manual threads is different, okay? And that's the one thing we haven't done yet is the manual thread. So we're going to go back over here to this male test, and we're going to back all this off back to here. So the way I'm going to do this is we're going to kind of redraw what we had before. Okay. Give me a second here. You guys will see how easy this is. So we've got that line. We got some relationship values here. We know that we want the top of that to be horizontal with, oops, we want the top of this one to be vertical with the top of this one vertical because the Z is running in that direction. We know we want this to be vertical with that and that to be vertical with that. Okay. We also know that we want this to be 60 degrees, but we want from here to here to be 60 divided by 2. Okay, and then what we also want is we want this equal value of this angle here to be that angle and this angle and this angle too. So we should have 60 on there. Let's just double check. Okay, perfect. So we want that to be a construction line. Okay, and then we know we're going to have a line here to here, and we know we're going to have a line from here to here. We know that we're going to have a distance from here to here, and we're just going to leave it that number. Okay, so now we know that we're going to have a height, and that should be a reference dimension. So this one is going to be here. We need one more line in here. There we go, and we're going to change both of those to construction lines. Okay. All right, so here's what we've established. We've got our 60 degree, we've got our pitch, and we've got our height. Now, because we've got our height, we know we can do this. That dimension is going to be this dimension divided by 8. And we know that this dimension from here to there is going to be this dimension divided by 4. Okay, at the bottom of that, we are going to have a curve, and we're actually just going to make all these construction lines for right now. At the bottom of this, we're going to have a curve. That's going to go from here to here, and then it's going to be tangent. So in CAD, in Inventor, you would just kind of draw the curve, and then you come up here to constraint and say, I want that to be tangent, I want this to be tangent, and everything will be fine because it starts and stops on that line. And then also at the top, we know we want, I'm just going to go from here to here. Actually, I'm not going to go from there to there. I'm going to go from someplace here, and I'm just going to pick it off so you can tell they're not even, but I'm going to touch here. So we have tangent here, we want tangent and tangent here. Once we do that, it'll square the whole thing up. So we're going to go tangent here and tangent here. I just wanted to show you that the constraints do work for that. So again, we'll go here, here, and touch that, and then make sure that this curve and that line are tangent, and this curve and this line are tangent. And then from there, we should be able to draw this line and draw this line. And what we want to do, the last thing we want to do is we want to draw a line from here to here. Okay? Actually, we're not going to do that one yet. All right, so there is our profile. What we want to do is call this pitch. So that's 17,524. Let's go up to our parameters, scroll down to 17,524, and we're going to call that pitch. Then we're going to create 2 dimensions of our own, okay? So let's add numeric. We're going to call this one threads per inch. And this one is not going to have a normal numerical value. It's going to have what we call a numberless value. It's not going to be an inch dimension. It's just going to be an arbitrary number. So here we're going to say, let's just say 20. And then we're going to give that one a key value. And then we're going to have our nominal diameter, which we already have. That's right there. So nominal diameter pitch is kind of what we need for this. Okay, let's go over to our iLogic, our form edit. Make sure we throw in our pitch. And then let's give us an empty space. Oops. I don't know if that's saved. It did not. Here, we're going to give it an empty space. I was putting in splitters earlier. That's not what I needed. I needed empty space. So let's go here, empty space. Hit OK. There we go. Now we've got body OD, body length, nominal OD for thread, thread length, and then TPI, threads per inch. So if we were to change this to 16, because we're doing a 3/8 16, we'd be fine. Now what we need to do is we need to create a formula for that, so when we do change that, it updates. Yeah, we got that. Okay, so pitch equals 1 divided by threads per inch. There we go. Okay. So if it's 16 threads per inch, then that should be a 16th long. So that's what we've got. Now what we've got to do is figure out a way to get this cut. So we know that we want the top of this curve to be our cut line. So what we can do here is, now that that sketch is active, what I'm going to do is I'm going to project that line, and I'm going to project this line. And then what I'm going to do is I'm going to kind of drag this down. And it doesn't matter where it goes out here, but for this line right here, what I want to do is I want the center of that line to be in line with this. There, now I can drag this around, and then what we're going to do is we're going to call this line here, we're going to just say that's like 1 inch. There. Now I can kind of drag it around and I can see what I'm doing. So I know that I want that line to be collinear with this line. There we go. Now I'm free to kind of drag this around. And let's just, what we want to do is we want to get this point in line with that. So let's do another constraint, and we're going to do a vertical or a horizontal constraint. We're going to say we want that point in line with that edge. There we go. All right, so now what we want to do is draw a line from here to here. So now we've got a closed profile, and we want to sweep that profile, or we want to coil this profile, if it's going to let us do it. Not going to let us do it. All right, let me change these two to tangent, and then I'm going to draw on top of that it should have just picked that up. I don't know why it didn't. So I do have a closed profile right there. So what we want to do is go coil. There we go. Okay. So we want to coil that around our X axes. Now we've got some options here. Okay. So there we go. So it went ahead and cut it in. All right. So now what I've got to do is then I've got to fill in this circle, because the reason for that, just so you guys can kind of see what's going on here. Oops. Is now if I sketch on this plane and I hit F7 to section it, you'll see that it's actually cut out some of this area in here, and I need to add that geometry back in. So I'll just do it this way. What we'll do is we'll just kind of draw this rectangle here. We'll just go over to here, and we'll say just revolve that around this and add that geometry back in. And then I've got some weird cut. I don't know what that line is right there. Let's figure out what that line is. Let's get rid of this. We're not going to do it that way. What we'll do here is we'll sketch in this plane. We'll project that line. And we'll go this way. With it. There. That should fill that in. There we go. Okay. So that's filled all that in. Now here's the beauty of this. So if I come into here and I say I want that to be 1/4 20, I can change this to 20 threads per inch, and then I can change this to be like 0.2449. So this has to equal, sorry, trying to figure this out as I go here. So this has to equal pitch, which it does. But that's not 20 threads per inch. Oh. Yeah, now this also has to match as well. So this is going to be TPI. There we go. And then I would change my revolutions to be like 12. Much better. Okay, there we go. We're getting it solved. Now what we want to do here on this bottom part to ensure that when we change that it gets covered up is we're going to want to figure out a way, instead of projecting that surface, because that surface is arbitrary, what we're going to do is find the center of the circle right there, and we're going to draw this circle to be nominal OD. There we go. And then we'll do nominal OD. Yep. Let's delete that, but keep the sketch. Yes. Now we'll go here, edit sketch. Then we're gonna do nominal OD into this part. We'll do part length divided by 2. Is that not a thing? Body length. Body length divided by 2. There we go. Okay, so that should cut us up. So now if we measure this again, okay, so let's go here, form. Let's check out what 3/8 was again. 3/8 was 369, okay. So if we go to 0.369 and we go 16, there. All right, so we're changing our thread on the fly now. Okay, so now we can take a look at cutting our relief here. And remember, we want that to go over to, let's see what that number is. So in this case, it was 3309, 2792, yeah. All right, let's go back up. .2792, and we should be all the way on there. There we go. Okay, so now we're kind of getting what we want. Works when you use 60 degrees. And we'll just do this one. We'll go this number times 3. There we go. And we're going to subtract that, -45. There we go. And then we'll go ahead and perform our relief cut. So now we're getting to a more automated process here. So let's try to do our relief cut. Well, we're still going to just do it off that plane view. So we'll go to F7 to section. We're going to sketch that out, but we're going to be able to use actual numbers this time. So we know we want to come up here. We want to figure out where our bottom is going to be. So we know we've got this number as our top. That's our nominal OD divided by 2. Okay, we know that. And then we know what our height is going to be. That's it. All right, so we've got our dimension here for height. So we want to dimension this. Oops, sorry, D for dimension from here to here is going to be height. And we can find it right here from our list of parameters. Did I not put it in there? Okay, 1 second. That's our reference dimension, height. Okay, let's give that a key. So D for dimension, height. Height, we're going to do height plus. So plus 0.02 divided by 2. Oh, that's not correct. Oh, we gotta subtract some stuff here. Okay. All right, so let's do this. We gotta do height. Height minus height divided by 4. Should give us that number. That's what we want. Okay, so we want that. Height minus height divided by 4. Yes, because we're taking up for that bottom circle. Then we're going to add on there 0.02 divided by 2. Nope. Which number am I getting wrong here? 0.02, not 2. There we go. Okay. So that's our relief cut right there. So let's do this. Let's make those constructions. That way we should be able to get this off each time. Okay, so now L for line. We're going to go out some arbitrary distance up to there to here. We know that we want this to be 45 every time. 45. 4, 5, and we know that we want this distance to be, let's just say 0.04, and we're going to call that 0.04 our relief cut. Relief cut offset. So we are going to revolve this, cut around that. There we go. So let's change this to relief cut offset. Relief cut offset. There we go. Key that. Oh, we want that 02 to be included in this too. So we're going to say bottom, we'll add this one in. We'll say bottom relief cut OD offset, and that's going to be 0.02. All right, so here we're going to copy what this says, and we're going to paste it in right here. Now I can change these numbers on the fly. Okay. Then what we'll do is we'll add in our fillet here. And we'll do this one. We'll do this one as relief cut offset divided by 2 divided by 3 divided by 4. There we go. And then we'll do this one as same thing. Okay, I think we got someplace now. So let's add those other two to our form. So we're going to be relief cut offset is being added to our form, and then this one is being added to our form. Yes, okay. There we go. Now do our form. So now, yes, so if I were to change this to 03, you'll see that radius gets smaller. And if I were to change this to 0.05, all that gets backed up. So there we go. Now we've changed this whole thing out. Once again, we can change this to 2449. And we can change this to 20. And our threads will go with us. Or we can change it to 0.449. And also change this to 13. So there, now we got a 1/2 inch, 1/4 inch, 3/8 inch, whatever we want. Oh, what we didn't change was this though, so we need to keep changing that. So if we want this one to match, this one would be it would basically be this. Relief cut, top relief. So we need one that's called top relief cut offset. And that one's going to be 0.01. Okay. So what we want to do is copy that, go here, paste, and then we want to height, top, relief, there we go. Nope, dang it. All right, well, we get this one set up too, but you guys get the picture. I don't want to sit here and write all these formulas while you guys are watching, because we're already an hour and 40 minutes into this. Anyways, you kind of see what's going on here with the threads and all that stuff. Hopefully this explains some of this stuff to you guys. I don't know how often you're going to use it, but this is really what I'm trying to figure out how to do in Modo. And if I can get it cut to where these are geometrically cut, whether that's a mop bullion or just regular bullion or whatever, then that would be great. I would love to learn how to do that. I don't know if anybody's going to watch this for an hour and 40 minutes. That's what I got. I'm out. If you guys got any questions, you can email me at chris@usdzmodels.com. Thanks.